All right, welcome back. Now that we've taken a look at the memory overview in terms of how it's managed, let's take a look at memory reclamation. As we said, if you are allocating or configuring, I should say, if you're configuring more VM memory than exists on the host, you're essentially creating memory overcommitment. What you don't want to do, though, is overcommit active memory. So overcommitting configured memory should be okay, but we want to watch out for it. If you wanted to be not concerned at all with memory management, do not overcommit memory, and you don't have to worry about these steps. So that's a choice that customers can make, right? Of course, you find that it's easy to create VMs, and so you might end up finding it's easy to create more VMs and more VMs until you run into a point of contention. So what do we have here? Basically, there are levels of memory overcommitment, and they are listed here in the order of severity. The system starts off with pretty minimal reclamation mechanisms, and then they get much more significant. And of course, the more significant, the farther in performance they degrade. So what do we have here? We have page sharing, what's called transparent page sharing, or sometimes known as TPS. There's ballooning, there's memory compression, and then there is host level or hypervisor swapping. Now, I jumped over that one there for a moment there, right? There's the thing called the host swap cache. Out of all of those things, all of those features are typically enabled by default. Transparent page sharing is a little different. It's actually enabled in VMs, but not across VMs though. Host level or host swap caching is something that does not exist until a customer configures it. So it's not even something that needs to be enabled. You actually need to purchase hardware and then configure that hardware to be used as a host swap cache. So that's not an automatic thing at all, but the other ones are pretty automatic. And the host swap caching is interesting because essentially what we've always had was that there was paging that could occur in the VM, that's ballooning, and then there's paging that could occur at the host level, that's the swapping. And basically there have been efforts over the years to further distance between paging in the VM versus paging at the host level. Paging at the VM is far preferable than paging at the host level. So the further we can delay those from each other, the better usually. So compression was added. Compression was added in, many years ago, vSphere 4.1. Compression is a sort of a stopgap between ballooning and swapping. And then in vSphere 5, there was the additional feature of having a host swap cache where you could designate a SSD drive, a local SSD drive, to be a host swap caching mechanism, as opposed to where we traditionally send host swap data that normally goes out to your swap partition, the swap disk, the swap file, which is in your SAN, right? So if the swap file is in the SAN, there's going to be a huge amount of latency trying to write to that, as opposed to being able to access your VM memory. And so the host swap cache's goal was to speed up the swapping activity by hitting a very high performing local disk, with the hopes that is close to memory access performance. It's not, but it's not the same, but it's as close as it's going to get with these high-speed disks. But, if you're basically trying to improve your paging and swapping mechanism, that may be trying to solve the problem in the wrong location. Usually, you want to prevent from having to swap to begin with. So that's what we want to watch out for. What's going on with our memory usage? So what do we have here? Transparent page sharing. This is not really memory reclamation in a sense. This is basically an ability to make memory management far more efficient, economize the way how a host is using memory for all of its different virtual machines. And so the original design of transparent page sharing, which goes all the way back to more than 15, 16 years ago, so older versions of vSphere have had this capability, where the ESX server's VM kernel can scan all of host memories and basically compare memory pages across the different virtual machines. And if VMs are actually trying to access the same 4K bytes of data, why have to duplicate or triplicate that data? We could just make one copy of that. This is good for when all the VMs are all running the same operating system. They're all going to have the same drivers. They're all going to have the same libraries. So essentially, when one VM loads that type of information into host memory and another VM is actually loading the same driver or the same library, why load it more than once at host memory? This actually uses memory so much more efficiently. So the way how the system does this, it will actually do a comparison across all the pages in memory. And it doesn't do this very quickly. It takes about an hour to do all of host memory. So it's not trying to be a big resource consuming function here. And any of the pages that have a hash calculation put upon them, where the different pages have the same hash result, then the VM kernel says, okay, well, these are good candidates to possibly be the same actual data. So then they do a binary comparison. And if two pages map to the same binary comparison, then the system says, oh, these are the actual same blocks of data. Let's make one copy, and then we can dump the other one to save memory. Now, these are all read-only types of pages here, right? We're not trying to have one VM write to the memory system so another VM could read from it. This is all read-only types of operations. If a VM actually tries to write to a shared page, the VM kernel performs a copy on write and gives the VM their own private page. The thing is, this inter-VM page sharing is actually no longer enabled. This is disabled going forward, right? This actually has been disabled. The inter-VM page sharing has been disabled for some time. Basically, if you kept a date on your vSphere patches, all of the vSphere 5 systems all got updated with a patch that basically disabled page sharing. vSphere 6 came right out of the box with inter-VM page sharing disabled. And there's good reasons why that's actually the case. But before we talk about that, let's talk about another kind of page sharing. There's internal VM or intra-VM page sharing. Now that's still available. That's still enabled. Right? That's where a VM's own guest may ask for common blocks of data. We don't need to make extra copies of those, so we can actually just collapse them into a single page. This happens a lot when VMs first initialize and they zero out all of their memory pages. Instead of having to actually zero out every single 4K byte size page for that VM in their configured memory, the VM kernel can actually just create one 4K byte size page, fill it with zeros, and then continually tell the VM that we've now mapped another page for them and another page. This reduces the overhead for memory management on VMs quite significantly. So we still do that, but we just don't do inter-VM page sharing anymore. And like I said, there's actually several reasons behind why it's disabled now. One of which is this. Basically, both Intel and AMD have added to their processors a second generation of virtualization offloading. Intel calls it extended page tables and AMD calls it rapid virtualization indexing. What it really means is that the processor's socket contains an MMU, a memory management unit, which basically takes the memory pages of the guest OS and translates them into physical address spaces. Well, it's always done that, but it's now offloaded and has also, in order to save CPU, mapped those 4K byte size pages into what we call large pages. Large pages are 2 megabytes in size. So basically what would have been a whole bunch of 4K byte size pages now get mapped into a single 2 megabyte page. Well, basically a far less number of 2 megabyte size pages. It's basically reducing the overhead on a per page basis. For the ESX server to translate virtual machine memory into actual physical memory locations, having to do this at large memory page levels has a significant drop in CPU overhead. So both Intel and AMD have implemented this. And this actually has a pretty big impact on page sharing, because page sharing basically is only comparing 4K byte size pages with other 4K byte size pages. When pages are 2 megabytes in size, the chances of two different 2 megabyte pages being the same is basically pretty non-existent, right? Having two 4K byte size pages to be the same is actually far more common. But once they get mapped into these 2 megabyte pages, then the VM kernel doesn't bother looking for page sharing opportunities in that case. So this actually happened behind the scenes. This happened both on Intel and AMD processors, and the customers were suddenly kind of surprised that, hey, what happened to page sharing? It just stopped. And this happened back in the vSphere 4 days. Kind of happened a little bit out of the blue. Now, another detriment to page sharing is the NUMA environment. When you have memory pages that are distributed across the different CPU sockets, right? You got some memory pages in one socket, you got other memory pages in another socket. To try to compare page sharing opportunities between CPU sockets, between NUMA nodes, also creates a lot of overhead. So the system just doesn't bother to do that. It only compares for memory paging opportunities within a NUMA node. It won't check to see it across NUMA nodes, just because of the overhead. We're trying to reduce overhead of memory usage with page sharing opportunities and trying to spend the extra resources to find common pages across NUMA nodes ends up causing more work than it was really worth the effort. So we don't do that. There's actually only page sharing opportunities looked at from within a VM perspective, and that's it. So again, what are we doing here with internal VM page sharing? We're looking for those zero fill pages and collapsing them into a single page. And finally, probably the real story as to why is page sharing really now just straight disabled, mostly because it wasn't really benefiting us, but it's also because of a particular study that was performed in a lab environment where it was discovered that if two VMs were running on the same ESX servers pinned to the same processor, and the administrator had full administrative access to the VMs and to the ESX servers, while watching one VM being scheduled onto that processor and then get descheduled, and then the other VM being scheduled on, it was possible to inspect down to the CPU's layer 1 and layer 2 cache to find some actual data that one VM was able to see that belonged to the other VM. And so due to that nature, with all the other elements, page sharing was basically disabled. But if you wanted it to come back, there are some interesting new changes to how page sharing can be enabled in a much more secure fashion. So if you want to have it, you can do this in a much more granular control. These are done with two different settings. There's a setting you apply to the ESX servers, and then there's a setting you apply in the VMs. Basically, the server setting is a setting that says, we're going to force salting on your VMs, right? Having each VM with their own unique salt value would prevent the VM from being able to share its pages with any other VM. If you don't force salting, then we don't care, and then page sharing can go back the way it was. So there's actually a host setting that you can apply. It's called this mem share for salting value, and that's what this host setting is. It can be set to 0, 1, or 2. Basically, setting it to 0 says, we're going to go back to doing page sharing across the board. We don't care what the VM setting is. It basically makes the salt value to every VM equal to 0. And if the salt value is the same across all the VMs can share with each other. And of course, a VM can always share internally. Notice none of the settings here have any impact on the individual VMs internally, but it's from VM to VM where these changes can take effect. Of course, that is not the default. The default is actually setting the host value to 2. 2 basically says every VM must have a unique salt value by default. And if every VM has a unique salt value by default, then no VM can share with any other VM. And that's what this is. This is what's basically a value called the VM setting. The setting is actually called, it's in the top right there, right? sched.vm/share/salt, right? You can apply that unique value to the VM. Right? If you apply that unique value to the VM, right, sched.mem.p/share/salt, the VMs will only share with other VMs that have the same salt value. So if you applied the same salt value to a whole bunch of VMs, then they share with each other. This is actually where it's kind of interesting. You could create teams of VMs that share with each other. So maybe you have 10 VMs that all have a salt value of 1. They share with each other. Then you have another set of VMs that have a salt value of 2, and they share with each other, but not with the ones that had been set to 1. So you can create teams if you wanted to. If you don't set this value, because the sched.mem.pshare.salt doesn't have a default setting, what the system will do by default will actually use another value. It's called the VCUUID value. This is the identifier that vCenter assigns to every VM. And so every VM is already going to have a unique ID. So if there is no sched.mem.pshare.salt value, because it doesn't exist by default, every VM will have a unique UUID value. And that right out of the gate means the VM won't have page sharing with any other VM. And so that's the policy of essentially saying, we're going to block page sharing across VMs as a standard. If you would like, as the administrator, you can choose which VMs will share with each other. That's basically by setting the sched.mem.pshare.salt value. The other setting, if you set the mem share for salting to 1, this changes that around a bit. That basically says, we're going to look for the sched.mem.pshare.salt value, which does not exist by default. But if it exists, we're going to go and only share with the VMs who have that value as common. But since that value doesn't exist by default, so not present is the standard, right? Then everybody defaults to 0, which means that all the VMs who have the same salt value will all share with each other. So it's just a different approach. Basically, setting this to 1 says, we're going to share as a default and block when you choose which VMs are to share. All right, so you allow for everybody and set exceptions for a couple. The other approach, setting this to 2, basically says block for everybody, and you can allow for a couple by setting your own custom sched.mem.pshare.salt. And that's basically what our next slide shows. It says, kind of the general concept here. Setting this host setting to 0 simply says you want to do inter-VM page sharing for everybody, the way it was back in the beginning. If you set it to 1, you're basically defining you want inter-VM page sharing as a standard, but we'll block on a per VM basis. Or if you set it to 2, that's the opposite. We're basically going to block inter-VM page sharing as a standard and allow for a couple VMs. So you have some choices here in how you implement this. Pretty interesting. You have to set this, you'll have to adjust both the host and the VMs. For it to take effect on a host, you'll have to either restart the VMs or you migrate the VMs off and migrate them back on. And when they land back on the host setting would take effect. And you certainly would want to make sure the setting is applied to all the hosts within the same cluster. All right, so that was a bit of an overview of some of the memory reclamation techniques, specifically page sharing. We'll actually spend a bit more time on the other reclamation techniques after we take a quick break. So we'll see you in a few minutes.